projects to go on to global judging to compete with the other 160 plus projects that will be picked. But what we asked them to consider was how well did the solution embody the challenge presented? How much of an impact will it have on the world? And how complete was the solution they created? We're here to solve real problems. So we want to see as much work as done as possible and give a good foundation for further work to happen in the future. So we've also kind of made that like this hybrid consideration. Like if we have two really awesome challenges and they really embody the challenge and they really will change the world, which one is a little bit further along, that'll be the tiebreaker. So without further ado, I'd like to introduce our judges. On the extreme left, we have David Hockman. Thank you. David was actually a judge for last year's SpaceApps Challenge as well, so we'd like to welcome him back and say thank you again. David is a consultant in tech-based development. He's also chairman of New York Business Incubation Association and was a software entrepreneur in the 80s. We also have Jen Gusted of the office. Jen is from NASA. She's with the Office of the Chief Technology Specialist. I'm sorry.
Chief Technologist.
Chief Technologist, okay. And she actually came all the way up here from Philadelphia. DC. Washington, D.C. She was so excited when she got here early in the morning on Saturday that she was just like blown away by all the wonderful work that was happening. And she said, we weren't expecting anyone to come until the evening, but she was here all day being an inspiration and chatting with everyone and answering questions, actual technical questions that people had. So thank you so much, Jen. And last but not least, and very much not least, Ron Guerin. Ron is a NASA astronaut. He's at AstroRon on Twitter. I don't think I need to say too much more. No more introduction there. Ron did a wonderful presentation for our kickoff party. We've actually made that available on YouTube. So his presentation was very inspiring. I felt very inspired by it, and I think everyone else who attended did as well. And I really thought that was a great launch to our entire competition. So let's get to the first presentation. We have space races. And they will be embodying the challenge of reach for the stars. Yes. Okay. I don't have it listed in front of me. I'm going to have it shortly. On deck we have.
My Space Cal.
My Space Cal. Gotcha. Space Cal NYC and My Space Cal. So with that, Space Races, come on over. Thank you.
What's that? Hi everybody, my name is Matt, and I'm proud to launch the demos for SpaceApps New York. We are happy to present to you today Space Racing. One of the challenges that's being faced is getting kids excited about science, technology, engineering, and math fields. And this is a pretty telling quote from a couple years ago. Basically saying that right now, we really aren't leveraging technology in the way that we could in order to really make sure that our kids are getting excited about these fields. There's just a ubiquitous presence of technology that we can utilize now. And in particular, NASA is trying to create more interactive games to get kids involved in STEM. And that's not just fourth graders, but all the way up to high school kids. Unfortunately, because of recent budget cuts at the federal level, this can become a bit of a threat. So we were really tasked with an idea of, well, how do we make a solution for this that can be open source, accessible, and also gets kids really excited about space. And that's what we're here for. So Space Races is taking kids on a journey that NASA experts every single day get to experience. They get to take a mission from scratch and basically create it themselves to the point where they can see the mission become a success. So Sumi is going to show us the demo, and you can see this is all a web-based app with some really, really cool graphics on it. And basically what we do is kids can start out by choosing what type of delivery vehicle they want to use. So we'll pick a medium launch vehicle. It's got sounds. And then we say, well, what do we want to take it? Do we want to go to deep space? Do we want to go use a rover? So we're going to go to deep space. Then we decide, well, what kind of propulsion are we going to use? We're going to make it like a nuclear-based propulsion system for our payload. Is it going to be more traditional or ion propulsion? And you can pick one there. So we're going to choose combustion. Then we decide whether that's going to be manned, unmanned. We also, by the way, can use leap motion to highlight this. So we will choose a manned mission. And then what happens at the end is, basically, after that's completed, a video shows up showing a sample mission that NASA has already completed or will be completing in the future. So this shows kids that you have been able to successfully pick all the objects that will allow a mission to succeed. So you can see that it's incorporating what NASA's already designed, live animatronics, and we can tailor this to every single mission and build a database of missions that are available. Now this is only the first step. So if you look at what, if you go back to the pitch, so if you look right now, we're at version 1, which is our current state. But then we've already developed a product roadmap. What we want to do with version 2 is a choose your own adventure sort of element, where we can actually see whether or not kids are a success or a failure based on the mission they want to complete, and whether or not they pick the right things to do it. And then version 3 is going to be more complex, where kids can start looking at launch trajectories, launch windows, things that are much more particular to a mission. Okay? These are the tech we used. A lot, thank you very much. And then our team has been awesome. Surprisingly enough, I'm the only former rocket scientist on the team, and everyone else on the team has been true rock stars, so it was just a joy to work with them for the past few days. But also, we want to continue working on this as a team. We have 15 independent developers who want to continue working on this project open source with NASA. So we're very, very excited to work forward with it. That's it, thank you.
Any feedback from Jones? Just hand the mic up.
Can we ask questions or?
Yes, just take the mic.
So I'm curious where you found the videos. So how easy was it for you to find videos based on the different scenarios from the NASA website? Was that something that was easy or not so easy to find?
Fairly straightforward. Some's on YouTube. Some is available on the NASA website. Yeah, so it wasn't too hard. Thank you.
Next we have SpaceAppsNYC, embodying the My SpaceApp Challenge.
Okay, so we took on the My SpaceApp Challenge. We are SpaceAppsNYC. And so the existing My SpaceApp shows all of the telescopes, or a range of telescopes that NASA runs, and it tells you what they're looking at and when they're looking at it. And so what we wanted to do with this was we wanted to keep it very functional, we wanted to make it pretty and attractive, we wanted it to be accessible to both the public and to scientists. So the first thing we want to do is space is beautiful, okay, let's use it. So around us on our calendar we have this plot, which is our galaxy, look at it, that's where we live. And here are all the dots of a range of telescopes and what they're looking at and when they're looking at it. But pretty is only one thing, it should be functional as well. So we've got an integrated calendar, we have a mouse over to the dot of the target name, we have the mouse position on that plot, gives you the galactic longitude and latitude. We have a filter on the satellites, which give you the target IDs. And we can also export any of this information as flat text, because scientists love flat text. That makes it very useful for scientists to come in and get a range of the satellites which are looking at things in a given date range. And if you click on one of these dots, it brings up a mobile overlay. And on there we have the name of the target source, we have the satellite information, and we also have an image, if there is one, from the NASA Extragalactic Database. If you click that image, then it will take you to the full set of all images that have been taken of that object in the past. That's great for scientists, they use NED all the time, but it's great for the public to explore what we've been looking at all this time. So I've got a live demo, which will show you this actually in action. Okay, so here's the map. And here's all of the observations popping in. And that's all time-ordered in the time ordering that happened in the period. Now if you scroll down, you can see here's the full calendar populated. And then if you click on either an object in the calendar or an object in the sky, you get this mobile overlay. Some of them have images, other ones have no images because we've never looked at them before. Okay? And you don't just need to do this on the site, you can also follow us on Twitter.
Is there a way to indicate up front with the dots or with the text whether there's a picture that exists or not?
don't currently have that in, we certainly could. It's just a piece of information that's retained.
Minus which challenge this is?
This is the MySpaceAppsNYC challenge.
Did you code it so that it's nice on mobile, or is it mostly for web-based on computer?
It is responsive. In the time available that we had, we didn't entirely optimize it for mobile, but this is all responsive, so it moves with Windows 7.
What would be the next step from the point that you're at now forward?
So we want to, well, it's an entirely functioning prototype at the moment, so it's actually really solid. I'm an astrophysicist. I'm going to go into work on Monday, and I'm going to tell all my astrophysics friends to use this, because this is a great way of figuring out not just what's being looked at, but it means we can actually search on any object in the sky and bring back every telescope, every date that's existed in that before. As far as I'm aware, there is no single source for that information, so from a functional point of view, this is exactly what I need.
Thank you, thank you. Just one note for presenters. We're going to have to do, unfortunately, have to do some microphone sharing, so just please pass the microphone back and forth during Q&A. And keep the mic a little bit closer to your mouth just so that everyone can hear you and we can get you on the live stream. So next up, we have Pipe by Pipe, embodying the M-Water Predicting Water Contamination Challenge. Take it away.
Thanks, Mike. So, my name's John. I work with an organization called M-Water, and before this I worked for NASA, so I'm very excited to be at this event. It's great to see you guys here. Our organization does water point mapping and water quality determination around the world, especially in East Africa. And one of the biggest challenges that we find is that a lot of sources that are considered to be improved water sources are actually contaminated. We're finding more and more about this worldwide as we do more water quality testing. So we've realized, from our own data and other data in the literature that pipe water is far superior to many of the other water sources like unprotected springs and so on. You see a lot of people having to use. The question that we had is how can we extend the pipe water services to the underserved? So the two questions that go into that are, one, where are the underserved population? And a lot of times we don't have good estimates of that from national census data because people live in settlements that are urban slums or other areas that are not recognized formally by the government, might not be even considered to be there. And then the other question is how can we make this something fundable and engaging to the public? So we had this idea percolating for a while called Pipe by Pipe. And the idea is, can we crowdfund the extension of pipe water services to people that are underserved? And so this site you're about to see demonstrates a way that we can engage the public in this in several different facets. So I'm going to pass it on to Sean to show it to you.
Thank you. So we decided to use satellite data rather than census data. This was difficult to get this data because it's in a proprietary format that we pulled from part of an observatory based in Colombia. So, go to the next screen. So we had to convert that over to GeoJSON, and that did take a while. But as you see here, we have more precise information. Each of the blue dots are water supplies, which are provided by M-Water, and the dark green is census data. So with the app, we can build a pipe so that the user can click on one place, and it'll say start building pipe, and another one. And you built a pipe of 218 kilometers. With that, we can provide to the end user just some sample on how much that would cost. And that's it. Thank you. Questions?
So, sorry, is there a plan to enable folks that might live in those areas that are underserved to be able to tag, hey, I'd like a pipe, and crowdsource kind of where there's opportunities that way?
Yeah, that's a great question, and that would be the flip side, that we can have people draw the pipes and see what it would cost, but then we can also have people say, I want a pipe in my neighborhood, here's where I live, and put it on there, and then we could make that, something that people could fund, through the site, people, identifying locally what their needs are, and us sort of responding to that with Yeah, so the M-Water app allows people to record water quality tests on their own. We use low-cost water quality tests. So what we could do is use the app to just map the pipe supply network. That would be one way, because we've seen the pipe water is generally clean. But we can also, from the app, we collect data on other sources, and we do water tests, and we can find out, how much more improved is the pipe solution versus what else, what people are using that.
Can you show existing pipes on the app?
Yeah, that would be the next step, and we'll be there this summer. We'll be getting, hopefully, they have GIS data that has like the whole network. We'd love to like bring that in using the technology they put together here, and it'll display on the map.
I did not envy our judges at all. Next up, we have ISS Spotter, embodying the Spot the Station challenge.
Hello everybody, my name is George Martinez, I'm part of the team. So NASA made it possible for any of us to know when the International Space Station is visible above us. We made it more accessible by turning it into an experience that we believe everyone will love. So how do we do this? We know the importance of social media these days, and I think that one of the aspects that's missing from what's currently available is the social aspect. And we do this by applying a couple of social APIs that will allow us to distribute this better. And at the same time, we think that we should beautify the experience that currently exists. We do this initially through Foursquare. We allow people to actually check in to the International Space Station. And how does it work? Well, we use this to check into the ISS when it's above you. And we define the radius. So you can't do this when it's somewhere else around the world. We use Twilio to alert people when the ISS will be nearby. So you don't have to be watching the clock all the time. Share the experience in Facebook, which is important. And we allow you to actually submit content. So it could be messages, it could be photographs, and we use AVIARY to do that. Some of the APIs that we've implemented are Foursquare, the ISS, Twilio, Facebook, and AVIARY. And I don't know if you can hear it, but we actually did activate the Twilio API. It should be going off any second. We have a couple of screenshots from what we're working on right now. We're going to go ahead and click through a couple of these, and then you can actually go ahead and check in. We allow the Foursquare to actually access that data. Once you're cool with that, click that. And you can see more of what we're doing right now. We look at these screens. So this is what's currently out there. There's this one model that exists right now for an ISS tracker. And you look at our Foursquare progress so far, and you can tell that it's pretty darn close once it renders.
We're over water right now.
Actually, we're above water, so. But it works. So, going back to our slide. Possible expansions, again, implement more social aspects to the product. This is definitely a mobile application. So we're definitely thinking about mobile, and last but not least, this is our team, and this is our website. Please visit this one-pager app.com, International Space Station. In it, we have our link to our third page. This is just a 48-hour project. If you guys like it, we'll keep working on this, but we need your input, so we look forward to hearing from you.
So is it currently only tied to Foursquare, or is it tied to Facebook and Twitter, or is that still work that you still have to do?
So I'm not a tech guy here, but I'll speak to what I know. Basically, Foursquare is just the location aspect of it. So once you do that, and you're ready to connect with others and content, then we ask you for permission to allow us to connect to Facebook.
So how hard would it be to implement a system where that astronaut on board could then either tweet or check in and say, hey, I'm looking out the window, I'm looking down at whoever's looking up? Would that work?
I think that could work, yeah.
We definitely want to give them some special administrative privileges. I think they deserve that. They can check in anytime they want.
That's the beauty of it, right? With us, it's whenever it's above us, but they can actually interact with them.
Multiple units. You can use multiple units.
So you use another one of our team members.
See the 15. For the user, it's next up, we can actually use augmented reality, so the user can turn up his camera and turn up the sky, and based on the position of the satellite, we can show him, because sometimes it's really hard to see it based on the weather.
Also, one thing that Commander Hatfield has been big on recently is taking pictures down and posting those right after he takes the picture down. So would there be a mechanism as well for them to point down people that click into or tag themselves in pictures that have been taken out at that moment?
Yeah, absolutely. We actually started hacking a little bit on that direction. I think that, I think one of the lines we said originally in our pitch, is about making it more accessible for a better experience. And a lot of that experience relies on social. And that includes photography both from our end and from their end. Thank you.
Okay, I am looking forward to checking in on the space station. I don't know about you.
Do it.
Next up, we have Renewably, and they embody the challenge for Renewable Energy Explorer. Who's got the mic?
Hi all, we decided to work on the Renewable Energy Explorers project for a couple of major reasons. And for one, only a small portion of the electricity that consumers are using today in the United States is very low compared to what the total amount of electricity being consumed in the US is. It's about 9.2% renewable right now. And also CO2 emissions are rising as we speak. They're about 22% higher than they were in the 1980s, and so we just really need to start thinking about building green. And so we decided to create this project called Renewably. And Renewably basically just shows, it's an API that links zip codes to what the current renewable energy index for a particular state is. And so what is the renewable energy index? So we created that based on the current consumption of renewable energy in a particular state versus the total amount of energy in that particular state. And so for instance, we built a couple of applications based off this API. For instance, this Google intensity map right here. And for instance, you can just see that for Oregon, it has a much higher index score than, for instance, the state like Texas. And the green for Oregon basically represents that Oregon homeowners and electricity users use a much larger proportion of their energy than those in Texas. We also built a mobile application for using this API. And the mobile application will allow you to basically figure out what your renewable energy index score is based on your location. And so, we hope to use this eventually. We hope to refine the data instead of on a statewide level, eventually into counties and individual zip codes to return a more accurate data point. And eventually we can see public governments using this as an incentive. A way to devise where to put incentives for renewable energy.
The data from the Energy Information Administration?
Yes. Yes. Any other questions?
So the granularity of that data is only at the state level? You couldn't find it at smaller levels for that particular visualization?
The granularity is available, but it's not all available in one place. So it'll require quite a bit of data mining in the future to obtain that information. But it is available through publicly available resources. It'll just be a long-term effort to sort of gather that and put it into a readable format.
Thank you so much. That looked really awesome. Next up, we have Cogito Ergo Sum, I think, therefore I am, which embodies the Why We Explore challenge.
Hi, hello everyone. First, I want to thank NASA to make this happen, and I want to thank Tutorial to make it. So, you see the phone number? Just call it now, so that you don't need to hear what I'm going to say. Alright? We try to answer this question, why we explore. And when I first look at this challenge, I think it's not a question, because why we explore is part of our human nature. And the reason we are standing here today is because our pioneer, way back in the time, they do all the hard work. And what we are doing today is not for us, it's for our children, for our next generation, for the future. So I do this because I want one day that my son can step up on Mars or even beyond the solar system. So what we did over this weekend is we made a podcast, and because we don't have the facility to play the sound here, so it's on that phone number, just call it and you will hear the voice throughout the history. And the inspiration for us to do that is because Einstein found that space and time is essentially the same parameter in the beginning of last century. So all those information in the past of the time, we want to bring it back to now. And that's what we did.
So then, just so I'm clear, you call the phone number,
Yes.
and it returns to you sayings from the past, or what is it that is actually, what do you hear?
You will hear all the giants from the past, Newton, Einstein, Kepler, who did all the great work, and then it will represent there will be music. So the music will represent the time and to represent the environment they're living in. So it's a podcast.
Were the quotes audible, or did you have to do something to actually, did you say them into the, or were they already pre-recorded?
Yeah, he was there.
Let's hear your voice.
Hello. The audio I did all myself. I did straight up improv on it. I'm pretty familiar with the history of the astronomers and scientists and physicists that contributed to a great amount of where we are today. The podcast basically starts with Copernicus and travels all the way to the moon landing. If I wanted to go to the Voyager, exiting the solar system, but that would have taken like an hour. You'd be sitting on the phone for quite some time, so I decided not to do that. But it's basically a radio transmission, and it weaves in and out with different sound effects, and there's different voices for each character. It's pretty fun, so I think anybody who listens to it will enjoy it if the sound quality is good. You can play it off the computer from the website, and it's a lot better sound quality. You might want to put on headphones, but I don't know, so people enjoy it.
How long is the loop? 8 minutes.
Is it 10 minutes?
8 minutes.
Oh, 8 minutes. And one thing, I am terribly sorry to Galileo, I forgot about him. So.
Thank you guys, and I'm just going to actually apologize that we unfortunately don't have the capability with our audio to actually play back stuff from presentation, so that's my bad. Sorry about that, guys. Next up is Free Flight NYC, the No Delays Air Traffic Management Challenge.
Thank you, sir. Where's my right here? All right.
So our presentation is short on visuals and long on code. I think our output was, given the time constraint, it's going to end up being a software design pattern for doing certain kinds of things, right? So the Free Flight Challenge was presented as a challenge to kind of to gamify and to express the idea of trying out different modes of controlling aircraft and routing traffic and things like that. The challenge didn't mention the Free Flight Initiative by name, I don't think, but that's kind of what I read into it. In 1995, the FAA director issued a challenge to issue a directive to figure out how we can have like less top-down control of how aircraft get to where they're going, right? So instead of a controller saying, this aircraft has to take this route to get from this airport to this one, there's local control, the pilot command, collection of electronics, GPS, onboard radar, nav aids, and what have you to figure out how to get from point A to point B and to do collision avoidance and all those things in the cockpit. So our design pattern, our teammate who's not here had the idea to use the Scala language and the actor facility in the Scala language to build this simulation. So why is that a big deal? Well, you can imagine a simulation like this involves lots of objects doing lots of things simultaneously. If you try to build a simulation like that with top-down control, with someone telling each object what it is it has to do, then pretty soon you have more top-down complexity than you can handle. So the idea behind the actor design pattern, which is not original, is that every object in the system is an actor. And an actor is something that can create other actors, it can respond to messages, and it can decide what its behavior is, right? So we used the akka.io framework. Can you just close the So if you scroll down a bit, scroll down this one, please. Thank you, sir. So, you know, the basic kind of hello world actor in Akka code and Scala involves creating some kind of object and passing in a message saying, okay, I greet you object, and the object responds, gotta go. Okay, so very quickly back to the so we found that we can do this. We can create a behavior map so that the switch case statement, the thing that says if you get this message, do this. If you get a client message, do that. We can externalize that, and we can add behaviors. Scroll down quickly, please. And we can add behaviors to an object.
I'm a software engineer, so I like to see code on the screen. That looked really awesome. I mean, and the more we can see of real-world solutions, the better. So thank you for that. Next up, we have Roy Hopper, embodying the Exploring Asteroids Planet Hopper Challenge.
Hi, we did the Planet Hopper Challenge, and the original spec was to improve visualization of exoplanets and to extend it to near-Earth asteroids. And what we did was, instead of say we wanted to use all the database of all 4,000 asteroids that are out there, we're going to focus on the ones that can be reached for a human mission. So what we did is launch a table of what's the shortest round trip, what can we get to the quickest. And we're targeting the NASA mission that they stated to go to an asteroid in 2025 and launch to about 25-foot wide rock. So if you look at here, we have the missions that would take the least amount of time, and you can also sort by the ones that would take the least amount of energy, which can be a little longer, but mean they're cheaper to launch, so you don't have to launch all the fuel. We built on top of the visualization of a website called AsteRank, which focused on asteroid mining. And we added new data here and added some touch controls, which we'll show you a little bit. So now Jason will talk about the future of the project and how it can be extended.
So one part of this is we want to make it educational because 50, 100 years ago, astronomers, the best way to collaborate was to pick up a phone and call, hey, I see a new asteroid. Then we got email, and then we stopped updating. So what if we had a tool that you could add your observations to a central repository and get those observations validated and verified by the community, and you could compare in real time? What if you could also have students ask questions about different research projects or different missions, etc.? And what if you could explore the simulation in an interactive way? We were using the lead motion controller in order to do that. And yeah, we just did that for part for fun.
So to add to that, the lead motion controller we programmed to be able to zoom around the solar system, and also and also to be able to zoom with 2 hands so that you can use minority report style gestures to zoom in and out, and you could really build anything on top of this. To click on asteroids, maybe lasso them, shoot them at other planets.
How did you calculate launch date?
We pulled from the JPL's database where they actually pre-computed all the launch parameters, and you can see that it shows days out, stay at the asteroid, days back. So that was all calculated by JPL, and we just used their data.
Did I understand correctly, you have built upon the Planet Hopper from last SpaceApps Challenge? Is that, or did you start from scratch?
We started from scratch, but we built on top of a different website called AsteRank, which was set up to see which asteroids would be the most valuable ones to find. And instead of focusing on that, we brought in the other data for manned spaceflight.
The next thing I want to see with that is a rocket ship on the screen moving to the rock.
We wanted to build that.
All right, phase two. Next up, we have Backyard Farmers from the Backyard Poultry Farmer Challenge.
Hi everybody, my name is Ryan, and I really wanted to tackle the Backyard Farming Challenge. First I want to say we had a really awesome team, and somehow a lot of us came together to make this happen. So the way that backyard farming relates to space is actually that it relates to being better stewards of our own planet. And on top of that, we can learn things about, for instance, energy budgets that may facilitate long-term space travel. And what we really wanted to do, we reached out to the backyard farming community to find out what their needs were. And it turns out that getting started is really hard. So in order to grow this community and learn more about backyard farming, we decided to make a website that jumpstarts backyard farming for people who might not be into the community, and also facilitate people who can, or facilitate connecting to other members within the community. Because our feedback was, people are always the greatest asset. So our solution is, we focused on making it mobile so that the information is always in your hand. If you're out in the field or out in your yard, you have what you need. And I think what I'll do is pass it off to give a little demo of what we created.
Hi everyone, I'm Viola. So how many of you have ever wanted to start a farm or have chickens? Cool. Does anyone have a farm here? Oh, only one person. So when, like Ryan mentioned, when we reached out to the community, the biggest thing was how do they start a farm? So that's where we focused most of our work on, was getting started. So we made it really easy to use calculator here so that you can specify how big your chicken coop would be and how many chickens you would get, and then what the materials were for that. So you can see as you change the slider, all the materials change, and so you have a list when you go to the hardware store or you're ordering online. So the other thing is, I mean, if you want a chicken farm, can you have a chicken farm, right? Like, you might not.
You're on time. So wrap it up.
Okay. So yeah, so we put the ordinance here, and then we have a how-to. So people will either want to buy chickens or they'll want to buy chicks, and so we'll have the easy information here to go and find that here. And we just have the FAQ for frequently asked questions, and I'm going to pass it off to Ryan because he's going to talk about our future roadmap.
Tell us about your future roadmap.
Okay, so we wanted to, firstly, there's no central place for ordinances regarding laws about having chickens. So we wanted to use MongoDB, set up a database for places to actually record all the different laws related to can I have chickens in my backyard? We also thought that using something like Foursquare to gamify the connection of backyard farmers to other people, other events would be a good idea. And integration of a tool like TalkBox, right, where I can show you my coop from my house just using a handheld device would be a great way to share information and connect people.
What about some sort of function if you have excess eggs and someone needs eggs?
Sounds good.
Did you look at any other types of farms besides chickens, or did you look at planting vegetables or crops or anything?
I think, well, we really wanted to focus on poultry in general, but we just picked chickens for now, but we would in the future expand, but that's another idea as well.
I think the other part of the idea is that chickens are, as far as meat goes, they're the most efficient converters of energy. So a chicken can produce about a pound of meat for every 2 pounds of food, whereas a cow takes more like 5 to 10. So it's about efficiency of conversion whenever you're climbing up the food ladder.
Thank you guys. That was a great presentation. I know in New York especially, I think a lot of people would like to use that product now that we can raise chickens here in the city. Next up, we have actually a group of high school students who came here to work this weekend. Pathways of Technology, Early College, High School. These guys were really impressive. A lot of people who saw them working were really quite impressed with what they did. So they're doing Lovely Blue, which embodies the Blue Marble Challenge.
Before I begin, I want to tell you guys, if you didn't say I was a high schooler, would you know? Okay, so I'm a 10th grader at P-Tech High School, and me and a group of peers decided to take on the big Blue Marble Challenge. We call it the Levy Blue. Alright. So the goal of the application was to create a platform website that consolidates a collection of space imagery and makes it more accessible to people. And so what we used was Sinatra, and we had a whole bunch of JSON in a text file, and Twitter Bootstrap, because we were not web designers. We sucked at that. So yeah, that was really sad because I mean, we would have really loved a beautiful layout for this, but we don't have one. And so a lot of more work was put into the back end, trying to parse the JSON and actually give these images to you guys. And so now I guess I'll demo it. Yeah, just demo it. Slide. Oh my God. Wrong way. Alright, so read it? Great. Okay, so this is the homepage. It's not really complete, but what would happen is you would be able to log on to the site, and from there on you would have a social experience when using and doing these photos. If you click on the pictures, you will be presented with photos from the JSON, and you scroll down, you can, no, don't, like, scroll. You're presented with some of the images, and if you click on one, and you scroll down, you can see the image, and you get some information from where the photo is from, and as well as the mission the photo is from. And you just scroll down some more. No. Just click on the image. Scroll down. Okay, click on the edit at the bottom. Below that, no. Close, okay, where it closes. Close. And then under that, edit, okay, edit. Alright, there you go. So we also tried to incorporate the Avery API to edit the photos that you find. Refresh the page, please. Sorry for the technical difficulties. Alright, Alright, so yeah, you're able to edit the photos from here, and hopefully if nothing breaks, you can save it too. And that's pretty much it.
So when you edit a photo and you save it, it saves it as a copy of the original photo?
Yes, you should get a link. Yeah, so you should get a link, and then from there on that saves your desktop.
Were you going to integrate it with any social channels, or was it a separate registration?
Yeah, the plan was to extend it to be able to save it to share it on Facebook and Twitter using their APIs.
Is there a plan in the future to tie it to a map, so that pictures from a specific area of there? Or in some way organize the pictures geographically?
Well, that sure would go into later the development process later. Yeah. One more thing. If you would like, we're doing a fundraiser to sell buttons. I'm sure most of you have maybe bought them. But donations start at $1 per pin. Yeah, so feel free to donate.
Awesome, thank you, yes. Definitely a worthy donation to make there. So we're just going to take a short break. We're going to switch out to bring in another judge and have a little confab with the judges. And don't go anywhere. We'll be back in a few minutes. We'll try and catch up a little bit to our presentation schedule. Everybody, welcome back to SpaceAppsNYC. Thank you, thank you. So we saw a really amazing and impressive round of our first 10 challenge presenters, and we're about to go into the second half, the next 10. We have added a judge to our lineup, so we now have 4 judges. I'd like to welcome Liz Berry. Liz is with the Public Laboratory for Open Technology and Science, grassroots self-starting citizen science data visualization group. She actually very graciously came to our pre-event on data visualization and citizen science. And we're very excited to have her here to add to the rest of our judges' perspective. So without further ado, I'm actually going to, where did my phone go? Oop. What's the next? Breathe. Breathe. That wasn't a command. That was actually a group. So what's the challenge they're representing? The Earth Day. Earth Day. So next we have Breathe, who is representing the Earth Day challenge.
Hi, my name is Andrew Liang, and I have to say, Ron's speech on Friday night really inspired me, and it really helped set me up for this challenge. Basically, you said that we have all the technology in the world right now to solve whatever complex problems we have. And I just like to look back and see we have done some amazing things so far. So Breathe is basically, we looked at the Earth Day challenge and we saw how the EPA has helped make our lives better and how a specific city is being able to breathe easier. Does anyone know this skyline? It's Los Angeles, right? Has anyone been to Los Angeles? It's fantastic, right? Except for what? Traffic. Well, okay, let's skip to the smog. So we have the smog. This was in the 50s. People were actually selling air for 50 cents in the 50s. It's almost like $4 today, right? In today's dollars. They were selling that fresh desert air. And this is from the 50s, but this is LA now. How do we get from this to this? And basically, it's through improvements of technology in cars, and also improvements with legislation, working with these car manufacturers, and improving the whole system at once. Now, when we looked at the EPA data, this is the carbon monoxide readings from Los Angeles for the last 30 years, every single day. If you notice, there's a huge peak coming down. And basically, carbon monoxide has been decreasing for the last 30 years because car technology has become better. But if you notice in the small levels, these peaks, the cars are still, there's still just as many cars, and we're still going through a cycle. And that's why a city is breathing to us. Now, we have a demo of a web app, so where we show all this technology and how these legislations come about. And if you have time, please check it out. We used a lot of tech. A lot of it was D3, and we had a lot of fun. Thank you.
So if we were to go to the site, what would we see? Can you give us some examples of some of the visualizations?
Well, most of the visual content on there right now is about which years were laws passed and which years like major boards came into play. You know, when the EPA came into formation, the California Resource Board for air quality control. So we are slowly building out the content, but that information is important to remember that we have solved huge complex problems already, and we can bring this into the future as well. And we should not forget, no challenge is insurmountable.
Thanks very much. Next up, we have the versioning goat, embodying the Syncing NASA Open Source Projects Challenge.
The versioning goat. Yes. So we set out to take on the most boring looking challenge we could find, on the face of it at least, which is syncing NASA code repositories. The problem is that NASA has code kind of like all over the place. There's some on SourceForge, there's some on GitHub, it's all over. So we just set out to build something that syncs everything to GitHub, basically, which is the task. That's our logo. I'd like to thank Sarah and the audience for pulling it together. It shows a goat consuming archive files, which are kind of like the junk that goats eat, and then excreting a beautiful GitHub repository, which is what the app does. It's a back-end thing, so that this is the only way we can really visualize it, a logo. All right, and so yeah, that just walked through really quickly. It's syncing a repository. It's pulling in a repository from SourceForge right now, and there it is. It created a GitHub repo using GitHub API, and yeah, we also have a little bit of we monitor SourceForge for updates using using SendGrid because they send out email updates. So we get a little, well, there's that. Anyway, the bottom line is we pull stuff into GitHub. Thank you.
Just how much was there in SourceForge versus GitHub that you had to pull over? Like, did you choose GitHub because it's easier to put things in GitHub, or was there less in SourceForge?
The challenge specified GitHub as kind of the best, most desirable place. And most of the NASA code stuff already is there, so yeah.
Awesome. Thank you. So, again, as a software engineer, this is something that I'm very excited about seeing. So next up we have the awesome asteroid mapper. It's one of our hardware challenges, and this will be embodying the CubeSats for asteroid exploration.
Thank you. Hey guys, I'm going to go through this pretty quick because we had a lot of people involved in our challenge, and that actually turned out to be one of the best things about our challenge. The Alvos brought their young kids, and yeah, So he wrote some of his first code today. We had somebody from so many different teams collaborate, and we ended up breaking up into several different teams that did some amazing stuff. So we're going through this really quick. So what we've built is a theoretical terrestrial prototype of an asteroid mapper that we would build into a CubeSat. The slides that are going by really quickly because we want to get to the demo are showing some of the work that was done. We had a couple people who built custom avionics. We had people dedicated to writing the mathematics necessary to do this. We had people building Arduino sensors. That was a three-dimensional exported map that you could take and print an STL file using Shapeways so that young people can get physical asteroids printed in their living rooms when we send one out to the next day. I'm not in sync. Don't pay attention to that. So what I would like to do is show you guys how this thing works. On that display is a real-time three-dimensional map that's being built by the ultrasonic sensor that is pinging out from that craft. It is going to operate autonomously. It is in your best interest to assume a defensive posture. I will say that. So let's give it a shot.
Okay.
Oh, great.
You guys are brave.
Yeah. Oh, come on. Yeah, I'll protect the judges. If it doesn't work, I get points for bravery. There we go. All right. Watch on the screen. And forward flight. Yeah, so now we're going forward, and you can see that it's mapping what you see on this screen. And so that's the demo. Yep. So there we go. And that's autonomous. Somebody wrote avionics software for that thing. It's crazy. I would like to show what a high resolution sensor is because ultrasonic is low resolution. So if you can look there, you can see these guys have a Kinect. That's a better example, of something that would actually work in space. So you can see they're building a three-dimensional point cloud. This gentleman over here is going to show you how we can control this thing with a leap motion sensor. So we have so much science and so much code and so much engineering going into this thing, and it's a collaboration of a lot of different teams, and this is exactly what this kind of thing is about. And maybe, perhaps, not anticlimactic. Anyway, it's off. That's okay. Oh, clapped off, sad man, yeah. All right. That's okay. We were ambitious in trying to get all this stuff in, but I think we got the point across. Please don't cut me in the back of my neck with it while I'm addressing the judges. So. There you go.
Can you?
Sorry. And this is the most dangerous part.
Yeah.
He created it. There's a gesture where he flips his hand like this, and the thing accelerates one set of rotors, decelerates another set of rotors, and spins itself in a barrel. So, yeah.
How much did you have coming into the weekend versus?
None of this. I owned a parrot drone and a big giant bag of parts, and these guys didn't know Node.js and had never flown a copter before. They hacked that thing, got into the onboard computer, rewrote the avionics, so that did not exist 48 hours ago. Yeah. Yeah, well, you can't, yeah, you can, so, I'll show you the map here. He's just going to walk it and show you how it's doing the real-time mapping. Yeah. So as you can see, as he's walking, it's building a three-dimensional point cloud. It's not terribly high resolution because the processor on board that Arduino is not super powerful, but you can see as he approaches objects, the point cloud gets closer and closer to you. Yeah, you see now that's a really close object that he just got. So we use an ultrasonic sensor, which obviously won't work in space because there's no air for sound waves to travel through, but it's very easy to program, so we used it here. But in a space version, you would use something like a kinetic hammer with a point cloud. You would use lasers that those two physicists happened to have in their lab and offered to let us use, but we couldn't figure out how to fit a power supply onto a quadricopter. And so this turned out to be like one of the most exciting weekends of coding I have ever had, and it was because of my incredibly brilliant team. And so I can't thank these guys enough for the work that they did. I did not think this was possible when we started.
So last question, what's next? How do you take that? What do you want that to be?
What's next is a couple things. One, the avionics that were written for that would be applicable in a real cube satellite if you did something like use an electrostatic propulsion unit to change the orientation of this thing in space. The other cool thing we could do is take the center out of that thing, make a three-dimensional gimbal, put an actual CubeSat in there, and detect the amount of propulsion that's coming out of the CubeSat so that we could make a CubeSat that would behave the way it would in space. And you can think about the number of science experiments that can't be properly tested terrestrially because we don't have microgravity, or at least we can't sustain microgravity for a very long time here. Using something like a quadricopter would allow us to simulate microgravity and perform these tests terrestrially, and the incredible amount of science that could then be done because of the things that you're able to test here on Earth would expand exponentially. So there it is.
I have to apologize. We're experiencing a technical sound difficulty. Oh, wait, did I hear a mic? We're just going to continue. We're just going to have to speak up a little bit, just so we can get everyone in the back of the room and on the ambient mic. But we should get the microphone back shortly. The next presenter up is this star map sculpture, which is embodying. The 3D printing challenge.
Yes, so what we did basically was use data from AstroNexus, which gave us data of a bunch of stars and map of stars, and we then turned that into an application which allowed us to print that and 3D print that. Yeah. I'm nervous.
Yeah. Okay, so basically our first rendition of it looks something like this. And all we have is a few stairs held up by a stick, and then, we sort of thought about it, and then we got this second wild looking thing. And what it actually represents to us is NASA's ambitions. Closing the gap between us and what we know about space and out there. And you don't see any space between the stars here? Yeah. Okay, we can go on. So the suggestion we got from the challenge page was to use Gaia mission from the ESA. From the ESA. And the Gaia mission basically would be sent to space and map over 1 billion stars. In our galaxy and in other galaxies. Oh, okay, I'm sorry. Yes, and then we moved on to we could use this database, which is a 100,000 stars database by Google Maps. This is how we did it, which we use Python and Excel and etc. Our next step, we actually wanted to build an application that would interface with Shapeways, so users or the public can actually build their own neighborhood of stars. Yeah, we wanted to make everyone NASA Shapeway for everyone.
So how did you decide the size of the different spheres in your model that has no space between them? Did you just eliminate space from that one to that one, or did you have some sort of multiplier?
All right, okay, so I can answer that.
actually solved. So we took each star and drew a sphere so that it would intersect with its nearest neighbor. And it has a couple of nice benefits. And primarily, apart from the whole philosophical side of it, it makes a printable sculpture. So the ball and stick one, again, you're holding something in free space, you have to have it touch the ground plane or touch something else that touches the ground plane, or it doesn't become printable. So in this case, when we filled the space so that the stars would intersect one another, they inherently became a convex manifold surface, and then we could print it. And the assumption, and so far what we've seen, is that each one will look slightly different, so it'll be unique. So you can create the big neighborhood, or you can create the system.
Next up, we have another really exciting challenge, Chillin' on Mars, embodying the Curiosity at Home challenge.
Hello, everyone. Okay, right here on it. Okay, hello, everyone. My name is Edwin Rogers. Basically, I'm new to this. I've never been to a hackathon before. This is something that I just kind of was lucky enough to stumble into. And, you know, I just came here and I didn't know what to expect at all. And then I saw this device. This device is called the Oculus, and it is a virtual reality goggle headset thing. And what I want to do is take a minute and everybody just close their eyes. And just take a minute and remember that inner child that saw the stars and said, you know what, I want to go there. Wherever it is, under the water, on top of a comet, maybe on Mars, maybe Jupiter, Venus, wherever there is, that's what this thing is able to take you to. It's amazing. Oh, you can open your eyes. All right, it's amazing. So we didn't know what John, I just want to give special thanks to James, this is his device. Among the hovercrafts and the sensors and all the other things, he just happened to have that lying there. So I just grabbed it. We didn't know how to use it. And what we did was, show you, I decided, well, okay, I'm a web designer. I'm going to build, take us to Mars. I'm going to build a website. It's called Chillin' on Mars, and because I want to be chilling on Mars. So what we did was we took the rover data that it's already on Mars. It's taking pictures. We imaged that with the help of John here and Glenn. They brought that in 3D. I don't know anything about 3D modeling. That information, the galaxy and the satellites and everything, and they put it into a 3D model using open source technology. So that means the software that they created this is free. It's readily accessible to everyone. So it's free to use. So we're going to demo that. So maybe we need a volunteer judge or somebody to, someone who hasn't done it already. Come on up here. We're going to show you how it works.
All right, so we built a 3D scene using Unity, which is a game engine. And essentially, this device is brand new. This is a Kickstarter project that got funded for $3 million. I was a backer, but I haven't seen it yet. This is somebody who was generous enough to donate it to our project, to let us use it. But basically, this immerses you into a scene. So just like we see right now, we have really big peripheral vision, and this allows you to see that way. It will go over glasses, but it might. Okay.
Second, I'm going to need your hands. Okay, now you're going to touch the.
Well, hold on. We gotta start first.
Okay, now you're going to touch these. Yes, up arrows and down arrows.
Okay, so this is what the goggles are seeing, but to your eyes, you're immersed in a 3D scene. So essentially, what we did is we built a sample Mars environment.
Don't worry. Move your head around and look at the satellite.
Here, watch out. Edwin, you're blocking the projector. So this is a sample Mars 3D environment, and we have Curiosity there. We have the Mars Reconnaissance Orbiter. We used Mars Reconnaissance Orbiter data to make a texture for the ground, and we also included the Viking probe, which was there, and so. But the idea here is that since not everybody can go to Mars, since Curiosity is there, and you want to experience it at home, that you could use a device like this, which immerses you in an environment, and you could experience Mars without being there. Because Mars is very cold, so you'd be literally chilling. Instead of figuratively chilling. So, I think we're good. Yeah. Thank you.
Any questions for Jess? Questions?
How extensive was the area that you modeled?
It was the landing site for Curiosity, I believe.
So the texture that we chose in the Mars Reconnaissance Orbiter, when Curiosity landed on Mars, the Mars Reconnaissance Orbiter was basically making sure that Curiosity landed in the right spot. So we centered the Curiosity model on this map with Curiosity where it landed. So. And that data is freely available on the high-res camera set. So.
Well, one thing we want to emphasize is that NASA has tons of data for like lunar, maybe underwater, Titan, wherever it is coming from. In a very accessible and affordable way, you can take this data and then create an immersive environment where you can explore. And it's not just like physical environments. Like you can explore a galaxy, a nebula, a cluster. That is it's not just going to Mars.
Does that device, the Oculus device, have the ability to also enter like you affecting the game environment? If you were to, pick something up in your immersive environment, is that possible, or is that not
have
something
that right now?
So at the moment, it's just for visual, and you use like a keyboard to interact with whatever program you're using. But that's what will come. This is brand new. I backed this project, and mine hasn't been shipped yet. It's $300, by the way, that Oculus Rift. But that'll come. But the point of it is to immerse you in something, so you really feel like you're there. I know you guys couldn't have tried it, but maybe later we can do some demos and show you more of it.
Using Unity is a great touch. Is the Oculus Rift going to be open source hardware?
So right now Oculus has a Unity plugin because it has to segment the display and it has to do camera tricks in order for this to work. But they are already plugins. I don't think they're out yet because Unity is a paid program. I think they're coming out with plugins for open source 3D modeling, Blender.
Yes, and I do want to mention that we built it in Blender and then just put it into Unity because that was the only one that had a plugin.
I'd like to make a quick note. Everybody, John Oquist is over there. Raise your hand, John. John was a participant in last year's Space Apps Challenge, came back this year. He was actually on one of the globally nominated teams from New York last year. Congrats, John. So next we have interactive weather map, an educational game tool, and this is embodying the Earth from Space Challenge.
First, I like to have my team to be here, just to introduce them. Who are they? Who are in my team? Excuse me? Oh, stand here? Oh, thanks. David and Aditya. It's a team collaboration, so everybody should be credited for what we have done. And then I would like to thank NASA and the community for giving us the opportunity to work on an exciting, innovative project, community-based project, and to serve the community. So, can you go to the next chart? Everybody watches TV, even though TV subscription is going down, but still people watch TV. And everybody wonders, how do this weatherman person come up with predictions of the weather. It's like almost like a rocket science. So we looked into the NOAA REACH database and see whether we can change the rocket science into people to understand and read the weather map and can predict the weather map on their own. So our goal is to teach kids how to read and interpret the weather map like a pro using the educational game portal that we developed based on the NOAA database and the images. So what target demographic we are addressing? Basically, the preteens, to grade 2 to grade 6, and then the teens. But the teen will be the phase 2 project. So next chart, please. Okay, so I did give you what are these goals for different stages. So for phase 1, this is our deliverable for today. So we try to address providing an interactive weather map game interface or the portal for the age 7 to 12. And then later on, our target is both preteens as well as teens with a very complex interfaces, not interfaces, but very robust images using robust weather map images from NOAA. So, and then these are our target goals for this phase 2, and how to also credit the kids when they do excellent jobs. So let's go to the, I would like to also mention here, I provided, can you go back to the location-based and localization interface support in the second phase. And the reason is that 3 of us speak more than 7 languages, including English. So we have a lot of understanding of the global culture. So we want to make it a globally reachable game with a localization feature. So that's our next step. Thank you. Thanks. Oh, I didn't even show the demos. Okay, please, show the demo, please. Yeah. So the demo for this. So you can see the demo here is the pressure map. So the kids are asked to identify how they're going to go from different isobars. So they get the concepts of how to define what is an isobar. So for temperature, you do the isotherms. So they will do that and then show the next one. So you can see now they understand what is a low pressure and high pressure regions, but through this game portal. So the next one, let's go to the next one. This is for next phase for the older kids. So you can see how rich is the interface now. And this is from NOAA databases. We use some of their APIs. So you can see now looking at that and looking at the standards from the weather map that the health portal will provide, they can identify what are the, based on those color. Those are the standard colors from the weather standards. They can identify what are the degrees. Any questions?
Can you describe again on the last page when you entered the 3 data points, what it is that they were trying to get out of the 3 data points? That just wasn't clear to me.
Can you go back to the image? Not this one. Yeah, the next one.
The colorful map.
The color one. See, they have all these colors. To us, it's a rocket science today. Then we provide the portal, health portal, as well as provide some indications you can see on the bottom what each color means based on the weather standards. They will predict, understanding the standards that are used, the standards, symbol standards, color standards, different standards there, weather used, and then they predict based on those standards what are the temperatures So it's just one example. It could be pressure, it could be dew points.
So we'll be presenting the second challenge by the same team.
Okay, we also have a second project. In the art from space, we didn't have the presentation, just the photo. So what we did was like looking at the ISS, the KLM images. So we said, okay, so the students will provide a portal for, we didn't have the time to upload the image. So we used this image. So ask the kids, can you guess the location where it is? Or can you guess what it is on the ISS pictures? And then they will come up with an answer. So then we'll go and check it out. Sorry, you're wrong. The exact location is below. What we did was like take that picture and now put it on the Google Earth. So they get the answers. So they get both feel like what it is. And then I remember when you're presenting, I was wondering, what are those? Couldn't tell. So I tried to guess. So with uploading on the Google Earth, then I can see what are really happening. So basically, trying to increase the inclusiveness in the students. Any question? Thank you again, everybody.
It's really great to see so many challenges geared towards STEM education. I mean, that's something that's really, really important here. Next up, I would like to have Go Rover, embodying the Lego Rovers Challenge. Take it away.
Hi everyone, my name is Angela and that's my partner Carolyn, and we have our Go Rover right there on the desk. And so next slide, sorry. And our project is called Go Rover because we were on Saturday morning we were thinking of the Lego Rover challenge, but the most difficult part was we don't have Legos. So our project is Go Rover now. So we built it with aim that we want our rover to have the basic features of a car, like turn right, turn left, so it would be able to explore the environment, staying on another planet. And then we would let it carry an iPhone, and then it would wirelessly send the image to our laptop. That way we would know the surrounding and be able to operate the rover, saying it on another planet. And then in the future we were thinking of adding other sensors to the rover. And then during the challenge we built this, and it's still in progress because we couldn't get it to work with wireless for now, and we couldn't connect some of the parts because it was difficult. And but I think the most interesting part is the materials that we use, which is a lot of them are very common material. We use toy cars, we use coffee stir sticks, and olive oil, and thank you for ordering salads. And we use soap in the bathroom just to try to get the hardware working, and I think that's the most challenging part with hardware. We don't know what's wrong. Maybe it's because it's dirty or something. And we borrowed lighter, and we borrowed a lot of hardware from the awesome asteroid people. Where it was the flying project, so they lend us a lot of cool things, but we haven't been using them a lot yet. So we both want to thank people for borrowing, for lending us things. Yeah, that's it. And do we want to show YouTube video. Basically, just we have been getting it to move forward and getting it to control the speed with a simple program. That's it.
Awesome. I mean, that's collaboration and hacking all rolled into one. That's really great. Good job, guys. Okay, so next up, we only have 2 more left. So this one, I mentioned earlier that some of our ABR sponsors got very excited. Here we have Ankur from TalkBox, and they worked on the Tiny Seabots project for the Open ROV Challenge.
Hello, I'm Phil. So the
Fine.
Right. The challenge was to control this is an open ROV. It's a really low-cost underwater robot that can explore the sea. And we made it work over the internet, so kids, parents, all people can access it and explore the sea. So, does it work?
We think it works.
This is live.
So
This is live right now. This is in San Francisco.
We're going to start exploring. We got one of our robots in San Francisco that we can connect to, which is the one you just saw over Skype. And the interface we chose here to control it is actually the coolest part of what we did. We used one of the leap motion sensors, which is just a gesture sensor in midair, and it should be able to control our open ROV. So I'm going to start this up.
I'll show this.
Yeah. And
Yeah, it's pretty tight.
sorry, the screen's smaller than expected.
You have to be in front.
No, it's working. See the left arrow is going on and off. It's because I'm waving my hand to the left. And you should be able to see some of those pieces of paper over the motors move. So we wanted to get this underwater, but the facilities didn't allow us to do that. So we did the best we could, and
There's also the other one.
yeah, we're seeing a video. Are you
So
guys?
that means it's moving? You should trust them.
Is it moving for you guys?
Yes, it's very tight. Just before you guys start on the
Oh. It sounds like it was moving. Oh.
Yeah, that's the rudders.
That's what it sounds like, yes.
So it does work. But we're making it so anyone can register their open ROV around the world, and then anyone can use an ROV around the world, anywhere around the world as well. So you can explore the sea from your home.
To be honest, the biggest challenge involved here was dealing with Wi-Fi that wasn't completely reliable on both sides and firewalls on both sides. So there was a lot of hacking around to make this work, and we're happy with where we got to, and we think it has a lot of cool potential. Bye guys, thanks for your help.
Basic question about it being underwater. So once it's underwater, the communications underwater is a little different than above the surface. So what's the plan for enabling the communication
So
underwater?
what they currently do is use a very, very long Ethernet cable and connect to a computer. And then we're really interacting with the computer and proxying in. Yeah. So, you can get as far as an Ethernet cable.
So OpenRP was a challenge at the last year's SpaceApps Challenge. So can you just give us a little feel for what you added on to and what this piece of it is?
Right, so the OpenRV is just it's a cheaper kind of underwater exploring robot, and we made it so you can access those from the internet.
So before you couldn't access it on the internet, you can only access it locally when you're right next to it. So now anyone could put their open ROV and make it open to the world. So anyone can support it.
Did you think about social integration? So when people actually log on and register and want to use it, that they link up with their Facebook site, or they can check in their ROV at different parts?
Sure. Yeah, absolutely. Like, we wanted to take pictures and you can share that, or maybe even crowdsource certain explorations. Like maybe someone sees something that no one's ever seen before, and you can take a snapshot. That'd be pretty cool.
Awesome. Thanks, guys. Okay, so we've reached the end of our presentations. We have our final entrant, a original challenge, not particularly tied to any of the SpaceApps challenge. I'm told that this project is called Monstro.
It's our mascot. Thank you. Hi everyone. Thank you for showing up. This is our mascot for Monstro. I did this act with Brooks Swinnerton and John Gottfried. And what we did was we basically built a autonomous dirigible based on Arduino that can take any sensors and move around. And we built it with just some balloons and Arduino parts. So basically, from scratch, built a rover that can move around or take sensor data and explore its environment. So without further ado, let's introduce Monstro. So right now we just have a few distance sensors, one on each side and one on the front, that take distance readings and then control the fans in which given direction. So, but it's got an Arduino on the bottom, which we've tested against a cell phone attachment and a few other things. So we have communications or Wi-Fi or whatever else you can attach to Arduino. Thank you. Modular, you can have another one.
And it's shiny.
It is shiny.
Were you influenced by any other related projects, such as BlimpBot?
Yeah. And to tell the truth, John and I both have been collecting various Arduino projects and kind of looking at doing something with a blimp for a while. This was just a great hackathon to do that at. We want to know a tutorial for other people to use.
Yeah.
Yeah, so yeah, it just it controls its direction based on sensor readings. So we can have it seek out various environmental readings or whatever, which is very much in the spirit of exploration for this hackathon. Thank you.
Awesome. So I have to say I'm. Sounds cutting out a little bit there. Very impressive array of projects. Oh, I'm sorry. You're actually coming. Okay, cool. Which challenge is this for?
For Reach for the Stars. All right, so as we struggle to make this presentation go, my name is Volkan, and when I came here on Saturday, we wanted to address one problem, which is to how do you sustain the inspiration and continue to inspire kids to reach for the stars, and to become inspired by making rockets and going to space. And we thought that when we were growing up, we didn't have the tools that we have right now. I mean, who doesn't want to go to space here? Everyone of us do, but we don't have the means. So how do you make it possible to have kids collaborate with experts, and how do you make that, create an online community to make that possible? So we decided to build this prototype for Make a Rocket Foundation, and so the idea, the idea is that rocket science is hard, and it doesn't have to be. I think part of the problem is just the way that it's explained. It gets really complicated. And we were inspired by this comic, XKCD comic. He made a comic where he explained a blueprint of a rocket ship using only 1,000 most commonly used words to explain it to a kid. So I thought that was really inspiring, and I think that it could be done like this to inspire kids to create projects that can actually become rockets. And you can build rockets, prototype them using 3D printers, and Shapeways API is great for that. So we wanted to first of all invent a process for collaborating, and then to ensure that everything is all in place. And so we built this website. It's at makearocket.heroku.com. You can actually go there and check it out. So we are still working on the process of how people would work through this. Go through the inspiration, ideation, prototyping, and lift-off phases. And you can actually go here and become an Imagineer, enter your name, find your blueprint, upload it, and then lift off. There's a gallery that I started. This is a rocket with a story. I think every kid has a story that they can tell about a rocket. So if you can just start aggregating these stories and the drawings of the rocket ships, then we can get people, builders, makers, to come on the site and collaborate and talk to the kids and help them through the process of building and pursuing their dreams.
So I think initially up front you said that you could 3D print these records. How does that interface work?
Shapeways is an API that allows us to import the projects that users create. So if you actually go on this site and become a maker, you sign up as a maker, we take your Shapeways handle, we look at it, and then when you come as a registered user, you can import your creations and associate them with a project or rocket.
Awesome, thank you so much. Sorry, apologies for that. I forgot that you didn't get into the email. So thank you very much, everybody. That's all our 21 presentations that we have available. So what we're going to do now is we're going to have our judges go back and deliberate a little bit. We're going to consider everything they've seen, and we're going to come back with 2 global nominations, so 2 presentations that will go on to global judging amongst all SpaceApp sites across the world. And we're also going to confab with our API sponsors and figure out who the winners of those prizes are. So we'll be back in 15, 20 minutes.